My name is Jenny Linnerud, and I'm working as an enterprise architect in Statistics Norway. And I'm looking forward to talking to you today about the Generic Statistical Information Model, GSIM. This webinar on GSIM is part of a series of lectures on the main projects undertaken by the high-level group for the modernization of official statistics. The vision of the high-level group is shown in this picture, where we have the common statistical production architecture on top, and lecture 1 in this series was by Therese, and she has talked about this architecture. We can see the GAMSO GSBPM, and Stephen Vale talked about this in the first lecture in this series. And today I will be talking about GSIM, and of course this is all supported by methods and technology. So what is GSIM? It is a strategic approach and a new way of thinking designed to bring together statisticians, methodologists, and IT specialists to modernize and streamline the production of official statistics. It is a reference framework of internationally agreed definitions, attributes, and relationships that describe the pieces of information used in the production of official statistics, information objects. This framework enables generic descriptions of the definition, management, and use of both data and metadata throughout the statistical production process. So what is the relationship between the GSIM and the GSBPM? The GSIM and the GSBPM are complementary models for the production and management of statistical information. GSBPM models the statistical production process and identifies the activities undertaken by producers of official statistics that result in information outputs. GSIM helps describe GSIM sub-processes by defining information objects that are used by them, that flow between them, and are created in them in order to produce official statistics. So at the bottom of the slide, you can see the input being any GSIM information objects, for example, dataset variable and process parameters. These are then input to the GSBPM sub-process, which then creates an output which can be transformed or new GSIM information objects and produces process metrics. So what is an information object? GSIM is a model of objects that specify information about the real world, information objects. Examples of these include data and metadata, such as classifications, as well as rules and parameters needed for production processes to run. For example, data editing rules. GSIM identifies approximately 110 different information objects, which are grouped into 4 broad categories: the business, exchange, structures, and concepts groups. In this slide, you can see examples of information objects for each of these groups. For example, in the business group, you can see the information objects, statistical needs, and business process. Under concepts, you can see the variable, the population, statistical classification, and unit. Under structures, you have information objects related to data sets and data structures. And then in the exchange group, you have, for example, the exchange channel. So how did we develop GSIM? It was developed in 2012, beginning with a sprint in Slovenia in February, continuing with a sprint of 2 weeks in the Republic of Korea in March, and then an integration workshop in the Netherlands in November. This resulted in version 1.0 of the GSIM in December of that year. And that is a very rapid development for an international standard. So who was involved in the development of GSIM? There were 17 different organisations, and many of your organisations have been involved in the development of this standard. What are the benefits of using GSIM? GSIM enables statistical organisations to rethink how their business could be more efficiently organised by defining information objects that are common to all statistical production and regardless of the subject matter area. It improves communication between different disciplines involved in statistical production, both within and between statistical organisations, between users and producers of official statistics. It generates economies of scale. For example, reuse of information can improve comparability of statistics. It enables greater automation of the statistical production process and can be used to validate existing information systems. All of these benefits of using GSIM are being tried out in Statistics Norway. We are also using GSIM to communicate with other government agencies and with IT consultants. Our own participation in GSIM implementation has included translating the GSIM brochure and GSIM communication document to Norwegian. We did this for version 1.0, and we will shortly be producing these for version 1.1 as well. These have been useful for internal communication in our organisation. We also contributed to an informal task force on metadata flows in the GSBPM, where we looked at 20 GSIM information objects and mapped them to the phases in GSBPM version 4. We've contributed to the version 1.0 discussion forum with their experiences. And then we contributed to the statistical classification model, which was released in version 1.1 in December 2013. And we are currently trying out GSIM version 1.1 within our RARED project. So I think it's fairly clear to see that Statistics Norway supports the GSIM and recommends the GSIM. Otherwise, we wouldn't have done this much work in it. But looking wider than our own organisation, looking at the implementation in 2013 to 2015, 8 different countries contributed GSIM case studies in 2015. Some of the countries, for example, Australia, have been so busy implementing GSIM that they didn't manage to make a case study, but we know they are actively involved in GSIM implementation. And you can access all those case studies from the UNECE wiki. GSIM statistical classifications is a part of the model that statistical organizations have implemented most. In Statistics Norway, our vision is that GSIM should lead to a foundation for standardized statistical metadata use throughout our system. A standardized framework for consistent and coherent design of statistical production, and increased sharing of system components. Moving on to our implementation in Statistics Norway. We're working on a project, Remote Access Infrastructure for Registered Data, the RARED project. This is a cooperation between Statistics Norway and the Norwegian Social Science Data Services, NSD. And we aim to establish a national research infrastructure, providing easy access to large amounts of rich, high-quality statistical data for scientific research, while at the same time managing statistical confidentiality and protecting the integrity of the data subjects. The work is organized as a project and is funded by the Research Council of Norway, and the web page is included there. The RARED information model, the RIM, is an implementation of the Generic Statistical Information Model, version 1.1. We've based RIM on the GSIM design principles, and we can recommend anyone else to do the same. The design principles are very useful. Our RIM extends GSIM with 27 information objects that are mainly specializations, for example, to include different types of agents, producers, administrators, and researchers. It's a project that is still in progress, with completion planned for 2017. The potential benefits of RARED are to simplify the approval process. In our current system, it can take a year to get access to our microdata for researchers. We will provide quicker access to analysis results. More master's students will use our data. Currently, the approval process takes far too long for master's students. They wouldn't achieve approval until they have already completed their master's, so they don't even try. We want to simplify large, complicated studies by providing exploratory analysis in an early phase. We expect there to be more research and more use of our data. And of course, the more data is used, the better the quality will be. We expect to get feedback from the researchers that will make our system and our data better, improving the quality. The contents for 2017 will be demography, education, income, spelling mistake there, labour market, social security and benefits. We have already expecting to achieve a better transfer of knowledge within Statistics Norway. This project has suffered that several of the people who have an in-depth knowledge of the contents have stopped working for Statistics Norway and moved to other work outside of our organisation. So this system, we hope, will make the transfer of knowledge within our organisation much easier, so that when staff leave Statistics Norway, they don't leave with all the knowledge that we need to support the researchers. Overview of the main components. On the bottom left, you have SSB, that's Statistics Norway's data management system. From that system, the current system, we will then load data and metadata into an event history data store. Our researchers are sitting on the bottom right in the virtual research environment, where they will be using their browser to browse the data catalogue describing the data store. On the basis of this, they will extract an analysis data set, which again, they will run a virtual statistical machine on the analysis data set and providing a provisional output that they will not yet be able to see The provisional output will then run through the disclosure control system to determine whether a final output can be produced for the user to see, or whether the user needs to change their request before they can achieve a final output, which respects the integrity of the subjects and does not disclose their identity. So the researcher cannot see the data. They have a blindfold over their eyes. They don't see the data. But this is the key to simplifying the approval process. Many of the obstacles to the approval process are based on whether they can see the data or not, the microdata. If the researchers can only view the data through the metadata, then they don't need a long and complicated approval process. They can, of course, see results of the analysis of the data after this has been checked through the disclosure control system. So they will be able to see some results for a regression analysis, they'll be able to make and create their own variables, they'll be able to look at charts and figures, provided that the final output has gone through the disclosure control system. They will then be able to share their outputs with other colleagues in the same project and be able to use the outputs in their publications. Anyone who's interested in the many challenges with statistical confidentiality in RARE should have a look at the work session on statistical data confidentiality, which is happening on October 2015 at Statistics Finland. The RARE project is presenting a paper and presentation under topic 5, case studies. So if this encourages you to have a look at some more information on the GSIM wiki, then you can look at the GSIM version 1.1. The URL is included there. And in particular, for anybody starting in GSIM, I would recommend looking at the brochure and the communication paper, and then looking at glossary, where you'll find all the definitions of the information objects. And once you've done that, then you're welcome to go into the clickable GSIM, where you'll be able to see relationships between the information objects, and you'll also be able to explore the attributes of the information objects.